All right, boys and girls, we have ourselves product rule. Now, the product rule is when you have to take the derivative of a function times another function and you have to differentiate things separately. You're not dealing with coefficients here. You have two functions multiplied together. Now, this is the way that I do it. And some teachers, some professors might do it differently. Some might do it the same way I do. I view my two functions as u times v. So I would call u, I would call u v. And so the derivative of that would be u prime v plus v prime u. Some professors might call this f of x, or teachers might call this f of x, g of x, or just f and g. I don't like doing that because you're usually given f and I don't want to do double whammies, so I like sticking with u and v. So you take the derivative of the first guy, multiply the second guy, plus the derivative of the second guy, multiply the first guy, right? So I already called what I called this. Okay, so the derivative h prime of x is going to be the derivative of u. So here is u. The derivative of u is using the power rule, and the power rule applied to x cubed is going to be 3x squared. Okay? And I'm going to multiply that to v as is. So cosine x remains cosine x. Then we add. The derivative of the second guy is going to be the derivative of cosine, which is negative sine x, like so. And then you keep the first guy as is, so times x cubed. And now it's just a matter of cleaning things up. Okay, h prime of x is going to equal 3x squared cosine x plus, let me move this x cubed to the front and also make this whole thing negative, so maybe not a plus. Let's get rid of the plus like that. So let's make it minus x cubed sine x. So 3x squared cos x minus x cubed sine x is going to be a. That's going to be our guy. Find the derivative of the following. Y equals 3x squared minus 2x, all in its own parentheses, times a brand new quadratic, x squared plus 3x minus 4. Now, there's two ways that you can handle this. You can FOIL all this out and deal with the polynomial. I'm not going to do that. What I'm going to do is I'm going to use the product rule. Now, the way I handle the product rule is this. You take the derivative of two things, and I like to call them u times v. So u would be my u, and u would be my v. This first function is u, the second function is v. Now to take the derivative of something times something else, you take the derivative of the first function, multiply the second function as is, plus the derivative of the second function, multiply the first function as is. Okay, so I'm going to leave this like that. All right, so let me kind of color code things a little bit. I will call u blue. So if I want to find out what y prime is, it's going to be the derivative of the first guy. So lots of parentheses, I'm going to keep those parentheses there. Okay, u prime is going to be the derivative of 3x squared minus 2x. So this is power rule the whole time. The derivative of 3x squared is 6x minus the derivative of 2x is just minus 2. Okay, so that's u prime. And then v, we'll do purple. We'll do purple for v. Regular v is just going to be regular v. X squared plus 3x minus 4. Okay, then we're going to add v prime, which is going to be the derivative of the second guy. So the derivative of the second guy is power rule, power rule, power rule. The derivative of x squared is 2x. The derivative of 3x is 3. And the derivative of a constant just goes away. Okay, and that was v prime. Then we multiply all of that times the first guy not changed at all. So that was 3x squared minus 2x. Now I'm going to leave this as is. I know it looks sloppy, but the purpose of the product rule is to avoid foiling. And so why would I foil twice if my whole goal was to avoid foiling in the first place? But that's going to be my answer right there, is this ugly mess. That's how you do product rule if you're allowed to just do it without having to foil anything out. Okay? Gross looking, but that's it. Find the derivative of the following. You have x to the negative 2 times e to the x cubed plus e. This is a function times a function. All right, x to the negative 2 multiplied to this parentheses. And what I don't want to do is distribute that out, because then I'm probably making myself more of a mess. Or maybe I'm not. I don't know. I'm going to leave this as is, because the goal of this section is to deal with product rule anyway, so I'm going to view this as product rule. The way I handle product rule is if you have a function times a function, I like to call it u times v, you take the derivative of the first function and multiply it to the second function as is. Then you add the derivative of the second function multiplied to the first function as is. So following these steps, I would say that y prime is the derivative of the first function. So the derivative of the first function is me taking the derivative of x to the negative 2, which is just power rule. So you drop down the negative 2, subtract 1 from negative 2, and you have that. Okay. Now you keep the second function as is. So e x cubed plus 3. Just like that. Then you add the derivative of the second function. Now I know what you're thinking. E to the x, that's not e to the x. That's e. You're treating e like a constant. So this is power rule. So you drop down the 3, you multiply it to the e that's there, and you subtract 1 from 3, making it x squared. Then you take the derivative of 3, which is nothing. So we'll leave that as that. Okay? Keep that multiplied to the derivative of, the regular function as is. And it gave it to us like that, so I wonder if this is something where if you saw this on a test, they'd leave it with the negative exponents. I don't feel right. I don't feel right doing it. So I'm just going to simplify it one last step. All right, I'm going to keep negative 2 upstairs, right? I'm going to move x cubed to the bottom, and I'm going to keep x cubed plus 3 in parentheses upstairs. I'm going to add, I'm going to keep that up top, 3ex squared in the numerator, move x to the negative 2 to the bottom, and I'm going to answer it that way because it looks a little bit nicer. I'm not going to bother trying to combine fractions because I don't want to. These are my videos and I'm sticking with that. So, I don't know. You might see this as an acceptable answer. That just looks a little bit better, so I'm sticking with that. Yeah, that's product rule for you. Fun stuff. Given that h of x equals f of x times g of x, f of 3 is 7, g of 3 is 2, f prime of 3 is 4, and g prime of 3 is 10, find f prime of 3. All right, well, we have all of these f of 3's, g of 3's, f prime of 3's, g of 3's, and we're basically being told, hey, look, product rule, let's be cute with it. Okay, well, product rule in its general form says this, and I'm going to use the actual form. If you watched all of my videos, I like to use u's and v's, but since they're giving me the f's and g's, I'm going to keep it that way. So h prime of x is going to be the derivative of the first guy multiplied to the second guy as is, plus the derivative of the second guy multiplied to the first guy as is. Which means if I were to plug in 3, it would be f prime of 3 times g of 3 plus g prime of 3 times f of 3, like that. So h prime of 3 would be f prime of 3, which is 4, times g of 3, which is 2, plus g prime of 3, which is 10, times f of 3, which is 7. Now it's just a PEMDAS problem. H prime of 3 is 8 plus 70, and finally h prime of 3 is 78. So not a typical product rule type problem, but you know, it's all good, as the kids say. It's all good. Given that y equals ln of x over x, find dy dx using the product rule. Well, this is what the product rule says, and this is how I do it. Okay, if you have two functions multiplied together, you take the derivative of the first function, you multiply it to the second function as is, then you add the derivative of the second function multiplied to the first function as is. This doesn't look like that. That looks like something divided by something, not something times something. But if I were to pretend that there's an invisible 1 right there and move it to the top here by using a negative exponent, then I'm cooking with gas, baby. So that's exactly what I'm going to do. I'm going to make that x to the negative 1, move it in the numerator, and then multiply it to ln of x, and then apply this rule over here. I will let u be my u. I will let u, ln of x, be my v, and then follow these rules. So dy dx, right, the derivative, is going to equal the derivative of that x to the negative 1. This requires the power rule. So you drop down the negative 1, and then you take 1 away from that negative 1, like so. Then you multiply the ln of x as is, so you're still ln of x. Let's keep it wrapped in parentheses because it looks pretty that way. Now we're going to add the derivative of the second function. The derivative of ln of x is 1 over x. Multiply that to the first function as is, the original u, which is x to the negative 1. Now there's lots to clean up here, and so that's what I'm going to do right now. All right, dy dx is going to equal negative, I don't need that 1, so negative x to the negative 2 multiplied to ln of x. I don't like negative exponents, so I'll leave u as 1 over x, and I'm going to turn u into 1 over x. All right, like I said it already, I don't like negative exponents, so I'm going to make u negative, move u to the bottom, 1 over x squared times ln of x, plus, now these are two fractions multiplied together, so 1 times 1 is 1, x times x is x squared. Now let's multiply that ln of x to that 1 up there so we can combine these fractions. Dy dx equals negative 1 times ln of x is ln of x all over x squared plus 1 over x squared. Now, since these are two fractions that have the same denominator, we might as well just combine them. So dy dx is going to equal negative ln of x plus 1 all over x squared. So not the prettiest looking guy on the planet, but that's all right. It's not all about beauty. You know, the beauty's on the inside. That counts. That's what I hear. All right, well, anyway, thanks for watching. Like and subscribe. Find the derivative of the following. We've got y equals 5x e to the x, interesting, plus 2x squared e to the x, interesting, minus e to the x. This, boys and girls, is product rule and product rule again. Let me remind you of what the product rule is. The product rule says if you multiply two functions together, and I like to call one u, I like to call the other one v, you take the derivative of the first one, multiply the second one as is, plus take the derivative of the second one, multiply the first one as is. So we are going to do product rule twice. So you'll be my u and you'll be my v, and then I'll do that again. So y prime is going to equal, take the derivative of the first guy, so the derivative of, and again, by the first guy, I mean 5x, so the derivative of 5x is just 5, multiply the second guy as is, so times e to the x, plus take the derivative of the second guy, the derivative of e to the x is just e to the x, and multiply the first guy as is, so 5x. All right, so that's u. We'll clean u up in a bit. Let's do the same thing again. So 2x squared is going to be my u, e to the x is going to be my v. So we're going to add, because that's a plus sign, take the derivative of the first function, so the derivative of 2x squared is 4x, okay, times, keep the second guy exactly the way it is, e to the x, plus the derivative of the second guy, which is e to the x, times, keep the first guy the way it is, 2x squared. Okay. U are just the derivative of e to the x. So minus e to the x, nothing changes. Now I got a little bit of cleanup to do, so let's see if we can clean this up and see if anything combines. There's a strong possibility some stuff will combine. We'll have like terms here. We'll see what happens. 5 times e to the x is 5, e to the x, check. 5x e to the x, so 5x e to the x. All right, so you guys won't combine. You guys will, though. 4x e to the x, so I'll deal with that when I have to. How about 2x squared e to the x minus e to the x? Oh, okay, so several things combined. All right. 5 e to the x minus e to the x is going to be 4 e to the x. Okay, so you combine 5x e to the x, 4x e to the x is going to be 9x e to the x. And then just kind of hanging out all on its own is 2x squared e to the x. That's going to equal y prime. And that is me using product rule twice and then combining like terms. So much fun!